Okay, hey guys, what's up? Welcome back to another episode of the Real Hacker Hours podcast. We will continue working on the Phalanx static bug finder, and today we're going to be working on. I've done a lot of work since my last Real Hacker Hours podcast, and effectively what I've gotten working was the constraint generation, meaning that. Actually, let me show you what I mean in a second here. Okay, so let me pull up the test case and Phalanx. So we can go into basic fgets get 7. So what I'm trying to implement here with the static bug finding checks is, and also with the other checks, is when it's relevant, I want to be able to see like what comparisons are made to the relevant variables. And what I mean by that, in this case, this is a variable right into a stack buffer. However, what I'm curious of is this is a variable right. What checks are done on that? And we can see here that it checks that the size is less than 50. So in reality, this is not a bug. I'm wanting to implement that behavior right now, which I've already done some work with that. Effectively, TLDR, looking at the checks that we need to pass in order to reach a particular code or piece of code. In this case, the code is this variable right into a stack buffer, and knowing like realistically what are the constraints needed to actually get there, and we can check what the relevant like variables are and see what those constraints are to get like a range. Then we can just check the range. So okay, let's go ahead and run this. Phalanx tech process fgets 7 tech postscript Phalanx. Let's go ahead and run this, just make sure that works. So for this, it shouldn't flag it at all. Let's go ahead and just see. Okay, I'm going to start by getting rid of these print statements since they're from when I was writing a lot of like the logic behind this, and I don't want to deal with that extra. Just output I don't need, since when I will need output, it'll just make it harder. So let's go ahead and do this. I don't know where these are. Probably will not be in Phalanx, because, oh, might be. I'm just going to take a second and just clean up the printfs. Report, yeah, don't need any of that. Well, I do need those, so I can ignore the report printfs. Okay, so here we go. So this variable array context, actually let me go ahead. This analyze function, this function right here is how it's analyzing calls via just like iterating through all the references to the functions I care about. And what I'm doing is I'm writing another effectively like mirror copy of this code pass analyze function with context. Reason for that being is effectively the way I'm analyzing. So to take a step back, I have two effective methods of searching. One is like all references, so I will enumerate a list of like the functions I care about, like fgets, memcopy, whatever, and iterate through all the references to those. Second method I have for searching is you define certain address points, and I'll just iterate on from the code from that address point and analyze the code that way. Now, thing is, how I'm analyzing the functions initially with the by the references, I will have a reference of in a function to analyze. However, when I'm doing it, and I will actually like use that reference alone. Issue with doing it this way, trying to mimic that with just iterating through the code points, is that when I'm iterating through that way, I have the P code and have the calling function, but I don't really have a reference for that. in order to get a reference, I need to get the address to a particular call site, but then P codes, from what I've seen, don't actually have an address tied to them. Or like one that you can just like from a P code be like, what's this address? So I'm just writing another set of functions in order to analyze it by just a P code. At some point, I might figure out how to have both analysis methods work off the same thing, but for now, this is what I'm just doing. So for analyze fgets by context, it looks kind of similar to what we're doing for fgets. First, we just check if it is a variable size context, or if the size is variable, which effectively for that, we just grab the var node corresponding to the length one for the P code, and we just check is it constant. And if it is not, we do this variable right context, which effectively for here, we just go ahead, we get the size and destination of our node. Using the context, since from this we should have a single context per analysis granted, the same function call might be called multiple times if there's multiple different contexts we can call it from. So, and context is just the code path that we would have to iterate down in order to reach in a particular way. First, I just check, are there constraints on it, meaning that are there checks that we need to pass on the size var node. In this case, there is a check that we need to pass in order to reach it. If there is none, then we just report it as a variable right stack. And if there is one, we will just go ahead and simply get the size of the stack var node, get the max constraint size. The reason why I care about only like the max constraint, the reason why for the constraints I'm only keeping track of what's the maximum and the minimum value is right now I'm just trying to see is there like a possibility of the bug. And for that being, if we can write, it doesn't really matter from this right now if we can overwrite it by like 1 byte or OX 100 bytes. We just, can we overwrite, do we have an overflow? And then once the engineer is actually looking at it, it's up to them to decide like what's the range. So just go ahead and grab the max value that the constraint will allow for and the stack size, and just see is the max greater than the stack size. If so, report. And let's go ahead and wait, is that all of the, wait, get rid of this. I'm curious if calling no, I'm curious where the calling string is being referenced from. Oh, it's probably in here. Yep, right here. So let's go ahead and run this once. It should not have any real output from Phalanx. Yep, and just to give you an example of this constraint checking working, so we see there with fgets 7, this check prevents it from being a stack overflow. However, in this case, this check does not prevent it from being a stack overflow, and we can go ahead and just run it against fgets 08, and it will actually mark it as a bug. Yep, got flagged. With this, one thing about the reporting function when I do it just by a single context is I haven't figured out a way to give you the address, but I will think of a way somehow. Okay, cool, so moving on. For this, what I'm wanting to write next is a function just to analyze it if it is a static array. So for this, we can just do void static array context. We need the function to analyze, of course, the P code call up, context, size, and destination args. That should be here. Also, one thing I will also need is in here, so I can reuse this for multiple function calls. I don't need to specify the size and the destination indices. Let's go ahead. This is for fgets. The destination is the first. The size is the second. Let's go ahead and just run this just to make sure it didn't break anything. Okay, range is fine. Cool, let's go ahead and call this static right context. Exact same output as this. Cool, so we have that working, that is good. Now, what's next? We will, let me think. So we're still going to get the same size and destination for our node like in here. So let's go ahead and just have that. And we will also need to check if the destination of our node is from the stack. Also, the reason why this is new is var node from stack. I decided to like redo the stack detection algorithm. I was trying to not make it like architecture specific, but now what I do is I look at the defining P codes for the destination of our node and where it comes from. If there is like a pointer add or a pointer sub, I just look at the base argument and just see is it the stack pointer or the base pointer register for whatever architecture I am. Counter to that, or the downside to that, is I will have to, whatever architecture I'm running this against, I will have to specify that. However, the good thing about that is it should be way more effective at like catching those edge cases, because I was seeing instances where I was trying to like analyze a variable that Ghidra is not found, and the previous method I was by just recording all of the Ghidra stack variables was not working. So in the variable right context, I will look at the constraint. However, since this is a static size constant, the primary thing I would care about is the size, which, since it's constant, there is no checks need to pass. If this code is called, it will always be called with that size. So I just have to, I'm going to offload public void check static overflow. Logs var node destination var node long right size. I'm just gonna copy this code here because realistically we can do this to save us a few lines of code. Stack size max equals and we can go ahead just realize how we're doing against stack var size might give us some issues, but we will look at that for another day. Actually, I will look at it right after I get done with this. Check static overflow, we can do dest var node. And what is the right size, max right size? It is, for here, it is the max size of the constraint. And for here, it will be, the size var node dot get offset. Let's go ahead and run this and just make sure it runs correctly. Oh, we need the function to analyze. Let's go ahead. Func to analyze. Let's go ahead and add this since I want the reporting function in there just to eliminate code reuse. So one 370 static. Oh, misspelled static. Let's go ahead and run this. Let's see if it works. Okay, cool, that worked. Okay. So this is working just fine. Now what I want to go ahead and check it is against something like this right here, where it is indeed a static write, just to make sure that it is marking it properly. And is this negative? That's into a malloc buffer. It did flag it as did I read where? Yeah, I marked it as a variable because I had it as a variable, not stack. Right now what I'm looking for is the test case where it actually scans in. It's a static check, but okay, this one right here, where it scans in less data, that it is an overflow, just to check that it is a, or just to confirm the negative in that scenario. It's line 1319. Okay, let's go ahead and run this. Okay, flag that. Let's go ahead and check it against fgets 004, just to make sure it does not flag that. Okay, did not flag it. That is good. That is what I like to see. So where does that leave us? Okay, so we have the static check working for fgets. Now what I'm curious of is this get stack var size. How does this work? It looks at the defining P code. However, the issue for that is here. If you go over to context.java, is var node, new is a var node from stack. So with this, how I'm doing this new is var node from stack, this stack detection, it's iterating through all the source var nodes for the whatever peak or var node you give it. However, for the get stack var size, it's only looking at those single var node that you give it. So what I'm thinking about doing is just repurposing this from a boolean into a long. What I will do is when I go ahead and find like, oh hey, this is a source var node that is defined via a stack buffer or pointer or whatever, I will just go ahead and just, instead of returning true, since I have that P code, I will just calculate what's the offset and return that. And in the event that I can't find one, I'll just return some constant that means that, hey, this is not a stack var node. Reason for that being is that will enable me in instances where it is a stack buffer but like passed between like several var nodes or pointers. Doing it in this method will enable me to actually effectively trace through that, which will be extremely helpful. So for this, what will I do? Static context. Okay, for this, what will I need? I'll need the context, so I'll give it the context. Wait, actually, no. Since we're repurposing this from a boolean to a long, we will just need to do long stack size equals to context dot get var node stack size. I'm going to start off by like copying and pasting this into a new function and getting that working. And then after I get that working, I'll go ahead and change all of the implementations from new var node from stack to this other one, and then I'll see which other get var or get stack var size and calls I can actually change, because not all of them might have the context needed to do it this way. So let's go ahead and copy this into a public long get stack size. In the event that it can't actually well, in the event that it cannot find the defining P code, I'm just going to return 0. And the thing is, when you get down to here, we already have the P code, the defining P code. So for this, I could just, from here, I can iterate through the, actually, let me look it up. Syntax for Ghidra pointer add and pointer sub P code op, since that's the thing I'm looking at. Pointer add Ghidra. Does it only take 2? Yep, it only takes 2. Well, pointer sub takes 2, pointer add takes 3. Now, since it is a stack buffer, the offset should always be constant, meaning that the argument that we're looking for is going to be constant. I'm going to grab, for pointer add, looking at it right now, it's sort of like f-rate, where the size of the second and the third arguments multiplied together, so I can just do that. And for pointer sub, I can just grab the second argument. So for this, we're going to have to be calling this multiple times. So I'm just going to offload this to a public long get defining stack p code size, and we can pass it the p code op defining p code, and we can first, let's start off by getting the opcode equals defining p code dot get opcode, and then we have an if opcode is equal to pointer add else if opcode is equal to Ghidra pointer sum. Go ahead and do that. Now, what is going to happen here? We're going to need a var node inputs. It's going to be a var node array inputs equals defining p code dot get inputs. Let's do pointer sub first, since it's a little bit easier, since that has less. But length is less than 2, because it should have 2, one for being the base register and the other being the offset. And this is just a sanity check. We can just return 0. Var node offset var node equals inputs 1. Return offset var node dot get offset. And for here, what I'm going to do is I'm going to first do a check for if it is less than array inputs dot. The reason why I'm having both of these is there might be a scenario, I can imagine a scenario where I get a pointer add p code op with either 3 or 2 input arguments. I'm not sure if that third argument is actually required, so I'm just going to write test implementations for both. If it is equal to 3, var node offset var node 0. Long offset equals offset var node 0 dot get offset times offset var node 1 dot get offset. Return offset, and for here we just have the same thing. And in the event that neither are true, I'm just going to return 0. That's going to be my generic constant for hey, not able to get a stack var size or anything, something went wrong. Let's go ahead and run this. I was importing a binary that I already had, so that's why that failed. Context at 323. Okay, it looks like, okay. Return 0. Need to actually change the return type here from boolean to a const, or from boolean to long. Let's go ahead and run this now. Let's just make sure it works, then implement the get var node stack detection or size. Long stack size. Merge file phalanx13 right here. Okay, that works. Let's go ahead and implement this. So I can just return get defining stack p code size, defining p code. I will also need to do a bit more work on this get var node stack size, because right now I'm only checking if it's pointer add. Probably should also change that to pointer sub. Actually, I can wait a second. I'm already doing that, just a super long line of code. Okay, now let's go ahead and actually change this over. Stack size does not equal. We don't need this in this function. I was doing it in the variable, right? But it needs to be done here. Check if stack size does not equal to 0. Let's pass it the stack size. Okay, just realized a few things wrong with this, but oh well. Long stack size. So this is gonna break. I need to fix a few things. What do I need to fix? I am actually checking if it's from the stack in there. I've just forgot to do this right. Stack size, if stack size does not equal to 0. Stack size, let's go ahead and see if this works. Okay, that got flagged. Check if this got flagged. I'm just going to run some final checks and then probably going to wrap it up from here. Just to reiterate, like, what I will also need to do is right now I am effectively doing a check right here. I'm only looking at instances right here if the destination is in stack buffer. We'll need to add the additional checks and logic if it is from like a variable buffer or whatever, or maybe not. This is just analyzing a rate where the size is where the size is variable, but for some reason this is getting flagged when it shouldn't be flagged. Why is that? Read variable. This should be read static. Let's go ahead and read it should be read static check. So let's go all the way down to here again. It's been going to this function. Why is this not working? Or should be working. I'm going to go ahead and just print out the stack size in the right. Yeah. Stack size. Stack size is negative 120. Oh, okay. I need to. So yeah, since this is a 64-bit binary, and I believe the stack grows downwards in there, the offsets are negative. So I just need to math.absolute value this. Absolute value. Actually, don't need to do it there since a negative times a negative is positive, and a positive times a positive is. Actually, I'm just going to absolute value these, even though I shouldn't need to. I just want to do it for the safety. Absolute value. Might get an issue where it can only do it with integer arguments, but we will see. Okay, that worked. Let's check it against here. And what were the test cases with actual checks on it? Okay, that got flagged. That should be. Okay, this one should not get flagged. Okay, that did not get flagged, correct, but this one should get flagged. Okay, cool. So that's working. I'm going to go ahead and wrap it up here. Thank you for watching.